Hi, I'm Barbara Illowsky, and welcome to Elementary Statistics. This course, as you know, has many components, and I'll be here to do the video components for you. We have 12 chapters, and there will be 12 half-hour segments to the class. This first chapter, Chapter 1, deals with an overview of what statistics is and what this course is all about. What I'm hoping, my goal, is that when you finish this class, you'll be able to pick up a newspaper or read an article and ask yourself, does this make sense? Is this a valid study? Should I believe what's in the article, or should I not believe it and just say, oh, this is not following proper procedures and I just don't follow what's going on here? Throughout the course, you're going to be thinking statistically, and you'll be learning about how to think statistically in the class. You'll be using technology, either a graphing calculator or a computer program that you have on your computer. And you're going to be taking this information and applying it to the situations that come up. Well, the first thing I'd like to go over is what's the difference between statistics and probability. Statistics is the collection, analysis, interpretation, and presentation of data. So for example, we may want to survey the amount of time that students study statistics per week. That would involve using statistics. We may also want to do a study about how happy people are in their chosen profession. Again, that involves statistics. Probability, which is combined with statistics often, deals with the chance of the event happening. You might be interested in the chance of getting an A in this course. Geologists, for example, are interested in the chance of a major earthquake happening in the Bay Area here. So what they do is they gather data based on fault lines that are going through the Bay Area, based on what has happened in the past and how earthquakes have occurred, and they use that information, those statistics, to present information about the chance of another major earthquake happening. So they're combining probability with statistics. These two fields are often going together. Well, to start this chapter, we're going to be dealing with some terms. So let's say that we have a survey that we're interested in. We're interested in finding how long students spent at De Anza before transferring to a four-year college. Now maybe our population would be all of the De Anza students who ever transferred. But before we go into that, let me start to define some terms. These terms are all in your textbook, and we're going to apply them to this situation. All right, so here's the study that we have. We want to know the average time spent at De Anza before transferring. Our experiment means, what is it that we're doing? Well, what we're doing is we're doing the process of finding out the average time spent at De Anza before transferring. This experiment could be similar to any experiment that you did in a chemistry lab, in a physics lab, but very often statistical experiments involve surveying and going and asking for information as opposed to pouring chemicals together. The population is the group that we're interested in studying. In this case, we're interested in studying the De Anza students who have transferred already, because they're the ones who can tell us how long they took. Now, a sample in this case would be some form of subset of this. There are many students who have already transferred and already finished their time at De Anza. We probably don't want to go back and survey all of those students. So what we do is we take some form of a subset of these students, and these students are the ones that we would be surveying. From them, what we're going to find out is the average time that that subset spent at De Anza. Now, what we're interested in is the parameter. So we're interested in the average time spent by all De Anza students. We can't find that out unless we were to survey every single student from De Anza who ever transferred, which is not very practical. So what we do is we find the average time for this subset. And we hope that if we use proper sampling techniques, that this average would be a good reflection on what the true value is, what the parameter is. Now, in order to do this, we need to ask a question of the students or look up information. And the question that we're asking, our variable, would be a word type question. And so we would be finding the average time spent by one student at De Anza before transferring. So in other words, the type of question that we might say to the person is, how long did you spend at De Anza before transferring? And that student would answer. And the answer would be the data. So the data might be 3/4 or 10 years, hopefully not 10 years if it was a full-time student, or 3 months or 2.5 years. And so this information would be our data. So again, what we're going to do is we're going to do some sort of an experiment. And in this experiment, we want to find out some information. We first have to figure out who is it that we're interested in studying, and that would be our population. So our population would be the entire group that we're interested in studying. We want to find a parameter, and in this case, the parameter is the average amount of time spent by all students. But instead of surveying all students, we take a subset of those students, and that subset is called the sample. From the sample, we can find the sample statistic, which is the average for our sample. And we continue through for that. Next, it would be time for you to practice doing some of these problems. Well, once we collect data, if you look down at the definition that we have for data, we can see that it's some sort of a value representing the time. Well, this is fine in this type of example, but our data is not always going to be a number. In fact, we have different types of data. And the different types of data that we might collect, we have two main types, would be qualitative and quantitative data. And so these are just like what we have in English when we have quality and quantity. So I'm going to put up these definitions right here. Qualitative data is a word type data. And if you look at the word qualitative, it has the word quality inside. When you think of a quality of something, in your mind, you're not coming up with 7 as a quality. You're coming up more with a word type response. So some examples of situations that would yield qualitative data would be blood type. Although this is not a word, still, if you were asked your blood type, you would give A positive or AB negative. And so that's a qualitative type of response. If you were asked your favorite color, you might say chartreuse or mauve or blue, green. That would be a word type response. And if you were asked your name, that would be a word type response. So this is examples of qualitative data. The other type of data that we might have is quantitative data. And quantitative data is data that's a quantity. And if you look at this here, you can see we have the word quantity inside. This is data that is numerical. A quantity is some sort of numerical description. And within quantitative data, we have discrete data and continuous. Discrete data is data that is counted. And typically it asks the question, how many? For example, how many books are on your shelf? You would go about finding that answer by counting 1, 2, 3, 4, 5, and so on. You would count that. If you were asked, how much do your books weigh? That would be continuous data because it would be measured. We don't count weight, we measure it, and then we round it to the nearest, whatever we're measuring in, nearest gram or nearest pound or nearest ton if you're a voracious reader. And so the continuous data is measured. Some other items that are measured would be time, age, distance, volume. All right, and I'll do some examples here. We have some examples up here next. Let's look at some examples right over here. age. What do we think age is? Well, if I were to say, how old are you? You might answer rounded to the nearest integer, but yet your age is a measurement, and so our age would be considered quantitative, continuous data. The weight of your backpack, again, that's measured, so that would be quantitative, continuous data. The number of classes you're taking, well, in this case, you would be counting 1, 2, 3, hopefully not more than 3, and this would be quantitative, discrete. Your favorite baseball team. Now, in this case, you're not going to answer with a number. You would answer with the name. For example, the Giants, San Francisco Giants, might be the favorite baseball team, or the Oakland A's. Well, even though A's isn't quite a full word, we still consider this qualitative data because there is a quality there. The town you live in, again, that would be qualitative. The population of your town, though, would be quantitative. You count the population. If I was in Cupertino, I could go around from house to apartment to home and keep going through, and I would count 39,471, 39,472, and so on. But I'm still counting. So to keep in mind for the data, the first thing you want to decide, is it quantitative or qualitative? Once you know whether your data is quantitative or qualitative, if it's quantitative, you now have to decide, do I measure it or do I count it? And if it's countable, we say the data is quantitative discrete. If it's measured, we say it's quantitative continuous. All right, well now we know about the type of data, so let me explain a little bit about collecting data. A little bit ago, I mentioned that instead of surveying an entire population, we might just take a subset of that population called a sample. And if we sample correctly, and that's sort of the hard thing to do, is come up with correct, good sampling techniques, then we hope that our sample has representative features of the population. Now, students often say to me, well, why is sampling as good as surveying the entire population? Or, I don't think it is as good. I think that I really need to survey everybody. Well, if you think about it, to survey everybody in a situation might be difficult. Sometimes it's impossible. Sometimes it's not impossible, just a real pain to do or very expensive to do. And in some cases, it doesn't really matter. For example, let's say you're baking a batch of brownies and you put your brownie tray in the oven and you want to see if the brownies are done when the time is up. So you may open the oven and stick a toothpick in the center. And if it comes out with brownie gook all over it, you might decide, oh, I need to cook my brownies a little more. But if it comes out with completely clean, then you might decide, well, I don't really need to cook the brownies anymore. What I can do this time is I can just take them out of the oven. Now, sometimes for people who are a little bit neurotic, what they might do is they might say, gee, I know the toothpick came out clean, but I'm going to poke it one more place and see how it is. And if it comes out clean then, I'll know, yep, I'm done. Well, how many more places do you sample the brownies until you decide that it's done? Maybe you sample 3 places, 6 places, 9 places. What if you sample 9 places and the toothpick comes out clean? Should we do 200 places, 500 places, 874 places? Well, if you do that, what happens to your tray of brownies? It doesn't quite work. We just now have a tray of brownie crumbs. So in our minds, we've decided that if we sample in the middle or sample 1 or 2 places, that's as good as surveying the entire population of brownie. Here's another example. Have you ever gone to the doctor and the doctor says, I need to take some blood from you to test, do some sort of test. And you decide, okay, fine. And we have the blood taken out. The blood is taken out from us and just a little bit of a tube is taken out. Well, You go and you have your blood test, and from that little bit of a tube of blood, the doctor or the technician may come back and give you some information. What has never happened to me is I have never gone to the doctors and the doctor said, well, I need to take all your blood today. I'm going to test all of your blood. Come back tomorrow. We'll put your blood back in. Now, that's a ridiculous example, but you see, only taking a little tube of blood is showing that we're just sampling a little bit, and this is considered to be representative of how all the blood in my body might be. All right, those are just two types of examples. So now the question comes up of how should we sample? And there are some really bad ways to sample. That's the easy thing, is to come up with bad ways to sample. But there are also a bunch of good ways to sample. And I have a few sampling techniques that I'm going to put up here for sampling. The first thing we have to decide is, are we going to sample with replacement or without replacement? With replacement means that as soon as we pick a value, we put it back in to be picked again. So for example, if you've ever bought a lottery ticket, when a number is chosen, it is not put back in. That is sampling without replacement. So if you buy a lottery ticket and you pick the number 2, that number comes out and it's not put back in. If it were put back in, that would be called sampling with replacement. Another type of sampling with replacement is, let's say you have a bowl of candies and you want to pick and see what color you get. Maybe these are an M&M's type candy where you have several different colors, and you shake up the bowl and you pick one. Well, if you eat that candy and then you go to pick another one, you are sampling without replacement. If you put the candy back in, shake up the bowl again, and pick again, now you're sampling with replacement. And whether you sample with or without replacement typically depends upon what type of survey you're interested in doing and what it is that you want for your end result. For example, if I were to pick a committee of students to be on a committee and I wanted somebody from every single course on campus, and a person happened to be taking both math and English, I would probably not replace that person. If a person had been picked from the math side, I would probably leave that person out as one of the people and then go pick, if that person's taking English, then go pick somebody else from an English course. All right, that's the first part of sampling. Now from here, we want to make sure that our sampling is representative of our population under study. So let's think about what that means for just a minute. Let's go back to the exciting example of where we were surveying to see how long it took students to transfer. In this case, if we only surveyed students who transferred to San Jose State, we would be surveying a large number of our students, but that is not representative of all students who leave De Anza and transfer. So that would be a poor type of a sample to do, because of the fact that students transfer other places. If we only surveyed students who transferred being engineering majors, again, that would be a poor survey to do because we want to make sure that our sample is representative of all the people who transfer. All right, so we need to make sure that our sample is representative. Now, once we start sampling, we have several different types that we can do. Our goal is to have random sampling. And random sampling, there are four main kinds that we have. The first is simple random sampling. An example of this might be where you put everybody's name on an index card in a hat, shake them up, and just pick a bunch of names out. You could do that typically with replacement or without replacement. You could also use your random number generator to generate numbers on a calculator. That would be simple random sampling with replacement because a number could be picked before. Stratified sampling is where we divide areas into different stratum. So for example, let's say we want to pick 2 students from every class on campus. I would take each class on campus, and so those are the stratum, or each class, and I would pick 2 students from each group. and that would be stratified sample. Every class has a chance of participating, and in each class I pick 2 students. The next type, cluster sampling, is slightly different, and what we do with a cluster is we would take all of the classes on campus and randomly pick a few of them. Maybe Math 10 at 7:30 and History 17A at 2:30 and Film and Editing at 8:30 p.m. We take just those 3 classes, and within those 3 classes survey all of the members of those classes. This is very much how some major studies are done when focus groups are being studied. They'll survey one part of the population or one regional area and survey everybody in that group to see, to gain some information. And the last type would be a systematic type study. With a systematic study, what we would do is start someplace and possibly pick every nth name on a list. Again, for example here, let's go back to the case where we're interested in how long it took De Anza students to, at De Anza before they transferred. In this case, we might just start someplace. Somebody might give me a number, 3,000, and I look at the 3,000th name of all students who have ever transferred from De Anza, and then from there I might call every 20th number going down the list, or every 25th, or every 30th number. So it's a systematic approach to doing that. These are the types of random sampling, and what our goal is, we want to get our sampling techniques to follow one of these. Now, most often though, what we find is that we use what's called convenience sampling. This is not random. This is a type of survey where you're just walking around and you say, I'm doing this survey, can you help me out? Can you answer this question? And there is value in convenience sampling, but it usually does not end up with a sample group that's representative of the population. And that's the problem with this. If we were to do a survey on campus of how long it took students before they transferred, and we just walked into a group, some company, we're excluding everybody else, and this company may not be representative of the entire population. Or if we walked into a class at San Jose State and said, excuse me, I'd like to do a survey. If anybody here is from De Anza, how long did it take you before you transferred? Well, even though we think it might be representative, it may or may not be. Convenience sampling, though, is often what's used in advertising and in studies that are published in the newspaper, even though they're usually not very accurate. The last part that we're going to do for this chapter deals with once we collect our data and how we organize it. And so we need to do 2 more parts to this part. We have a frequency, which we need to define, and that's how many times an answer occurred. Our relative frequency is the percent or decimal or fraction that an answer occurred. And if this does not round, then what we do is we typically round it to 4 decimal places. So the relative frequency, what usually happens is either if our percent was 50%, that rounds to 0.50, but if we had 3/11ths, for example, that does not round, and so we round it to 4 decimal places. And we have cumulative relative frequency. These are the 3 main terms that we need to learn right now. Frequency is just how often an answer occurred. Relative frequency would be the percent of the whole. And cumulative relative frequency is an accumulation that it occurred. All right, let's look at a survey. This survey is in your textbook. We surveyed 50 students and we asked them how many books were in their backpacks at the moment. And this is the information that we received from this. I've organized this into a table right here. And you can see that in this table we have the responses 1, 2, 3, 4, 5, 6. And the frequency, this means that 11 people answered 1, 10 people answered 2, that's how we would read this, 16 people answered 3, and so on. If we sum up the frequency column, we should end up with 50. How many people we surveyed? That's how many people we surveyed. The last two columns that we need to construct are the relative frequency. You can see I started it and we're going to finish it. And the cumulative relative frequency. Well, how we get the relative frequency is 11 divided by 50 is 0.22. 10 divided by 50 is 0.20. 16 divided by 50 is 0.32. 6 divided by 50 would be 0.12. Then we have 0.10 and 0.04. If we would add up this column now, we're going to add up to 100% of our responses. And the last column that we have is cumulative relative frequency. This is an accumulation of all our data. How we read this is we would say now 22% of our answers were 1 or below. 42% of our answers are 2 or below, meaning 2 or 1. How we get this number, there are a few different ways. One way is to take 11 plus 10, add it up, that's 21, divide by 50, 0.42. Or we can add the two relative frequencies together. Or we could take the previous cumulative relative frequency, add the current relative frequency and get 0.42. So for example, we're at 0.42 here, and then if we add 0.32, we get 0.74. That tells us that 74% of our responses were 3 or 2 or 1, meaning 3 or below. We're accumulating the data. Finishing this up now, we'll add 0.74 plus 0.12. We have 0.86. We add the 0.1, 0.96, and we add up and we're at 100%. So just to summarize this before we end this first section, here we have a survey. We've surveyed and we have collected quantitative discrete data. We recorded the frequency, the relative frequency, and the cumulative relative frequency. The frequencies add up to how many people were surveyed. The relative frequency is 100%. And the cumulative relative frequency is an accumulation of each value and what percent of the data is that value or below. Well, this was the entire first chapter that we've had. And so at this point now, what you need to do is you need to take advantage of the resources in the textbook and on the website that we have and go through the problems and try doing these on your own. Best of luck to all of you. Bye-bye.